I'm Eli Philippi and I'm a 7th grader.
I'm William Holm and I'm also a 7th grader.
I'm Isaac Hutt and I'm also a 7th grader.
And our project is called How Does the Temperature of a Magnet Affect Its Strength? Our research question is, how does the temperature of a magnet affect its strength?
Our research said that the colder temperatures of magnets will be more effective than warmer temperatures, and when a magnet gets to a certain point in its heat, it will completely lose magnetism.
So, our hypothesis was that a magnet with a colder temperature would be able to pick up more paper clips because its particles slow down and increase the strength of the magnetic pole.
So to test this, we took 1,500 paper clips and we put them all into one plastic bin. Then we took 4 identical magnets, and we put one in the freezer, one in the fridge, one just sitting out in room temperature, and one in boiling water. We let them each sit for 30 minutes. When those 30 minutes were over, we put each magnet into the container of paper clips and let it sit for 5 seconds. And when we took it out, we measured the total weight of the paper clips to measure how many paper clips it picked up. And then after we did that, we put each magnet back in its area and let it acclimate for 5 minutes before repeating the test until we had 5 trials of each temperature magnet.
We found that the magnet that we put in the freezer actually had double the magnetic field as the magnet we put in the boiling water.
So, in conclusion, the magnets with a colder temperature have a stronger magnetic pull, and the magnets with the hotter temperature have a weaker pull until they eventually lose the magnetism at a certain temperature.
With that in mind, we accept our original hypothesis because, as we said, we thought that the temperature of a magnet would change its strength with colder magnets being stronger, and that's exactly what our testing showed.
If we were to do this same experiment again, we would definitely give the magnets 1, more acclimation time, and 2, try to speed up the process of moving the magnet from its environment to our test to weighing it in, as we could have lost several degrees of temperature when we were transporting it.
So, a real-world use or implication we thought of for the temperature of a magnet would be in maglev trains. So, if you were to cool down the magnet on a maglev train, it could possibly, keep in mind, we haven't done any research on this was a hypothesis, it could possibly increase the speed and efficiency of a train. So, along with our graph and table, we also made a line graph. So with this graph, we plotted the average temperature, or the average amount of grams paper clips the magnet picked up, and the temperature in which it was located, and made something called a least squares regression line using Desmos. This allowed us to calculate approximately the number of degrees that we lost per degree, or number of grams of paper clips we lost per degree that the magnet was heated up.
That's our science fair project. Thank you for your time.